Today I am going to explain construction of standard array in linear block codes. N comma k is the linear block code where n is small n is the number of bits in the encoded code word, k is the number of bits in the message vector. Number of valid code words is 2 power k. Number of code words means number of valid code words. Number of valid code words are 2 power j. Total possible received vectors is equal to 2 power n. Total possible received vectors. Suppose 6 comma 3 linear block code. The number of valid code words, that is equal to k is equal to 3, 2 cube that is equal to 8. Total possible received vectors that is equal to 2 power n is equal to 6, that is equal to 64 possible received vectors are there. Generate, second step is generate all valid code words using the generator matrix G. Valid code words, that means in this example 8 valid code words are generated by using this expression capital X is equal to M into capital G, where capital X represents the encoded code word. In this example, 8 code words are there. M is the message vector. The number of bits in the message vector are K. G is the generator matrix. Generator matrix order is K cross N. Message vector order is 1 cross K. Code word, generated valid code word capital X is equal to 1 cross N. 2 power, in this example, 2 cube, 8 valid code words. 8 valid code words is very, very, very important. Valid code words. Valid code. Next one, standard array. This is the standard array. The standard array is represented as number of rows and columns. The number of rows is 2 power n minus k, cross the number of columns is 2 power k. Number of rows, 2 power n minus k, number of columns, 2 power k. Calculate the number of rows required. Next one, select the first coset ladder as the all zero vector. Okay. All the rows of the standard array, is nothing but the cosets. At the beginning of each coset or row is represented as a coset ladder. Coset ladder is nothing but the error vector. Coset ladder is nothing but the minimum error vector. Select the first coset ladder as all zeros. Here all zeros as the first coset ladder as the all zeros. That is 0, 0, 0, like this. This represents no transmission error. First row of the standard array in linear block code is all valid code words. All valid code words are the first row of the standard array. These code words are determined with the help of this or expression X is equal to M into G. Next one, Select the remaining coset ladder in increasing order of Hamming weight. First coset ladder is all zeros. First coset ladder is all zeros. 2 power k cosets are there. 2 power k rows are there. First choose all vector weights. First choose all vectors of weight 1. Here first coset ladder of the first row is all zeros. 1, 2, 3, 4, 5. Consider this example. Next coset ladder of the second row is 0, 0, 0, 0, 1. This is the error vector. Next one. Next coset ladder of the next row is 0, 0, 0, 0, 1, 0. And the next coset ladder of the next row is like that. In this fashion, the last one is all these coset ladders weight is 1. First choose all vectors of weight 1. If more rows are needed, suppose 8 rows. 8 rows means here 0, 0, 1, 2, 3, 4. Next one is 5. 6 is 7. Totally 2 power k means 2 cube. 8 rows are required. Out of these 8 rows, at each and these 8 rows are nothing but cosets. At the beginning of the each coset or each row is nothing but the coset ladder. 8 coset ladders are required. 1, 2, 3, 4, 5, 6, 7 completed. 7 completed. 1, 2, 3, 4, 5, 6, 7. The last one, if more rows are needed means if one more row is required, construct the standard array. But weight is 2. Weight 1 is completed. Weight 1 is completed. No way to assign weight 1 to the vectors. Next one is weight 2. Next one is weight 2. If more rows are needed, in this example, one more row is needed. Choose a coset ladder of the 8th row having weight is 2. This one. Continue with higher weights until all rows are filled. Our required, based on that requirements, choose the weight of the coset ladder. Before selecting a new coset ladder, that verify that it does not already appear in any previous row. Here we need one more coset ladder, weight is 2. Suppose 0, 1, 1, 0, like that, 1, 2, 3, 4, 5, 6. If this weight is 2, this coded vector is not appear anywhere in the standard array. The standard array consists of 2 power n minus k rows and 2 power k columns. This is the row 1. All valid code words are placed at the beginning of the first row. The remaining second row beginning with coset ladder. Third row beginning with coset ladder, Hamming weight is 1. Fourth row beginning with coset ladder, Hamming weight 1. Hamming weight 1, like that. In this example, one more coset ladder is required, 8th row, but Hamming weight is 2. The remaining elements, total 8 cross 8. In this example, 8 cross 8, 64 possible coded vectors are there, are appeared in that construction. This value is obtained, this code word is obtained. The rows of the code word is obtained. Perform exclusive operation on this coset ladder with the code word. Perform exclusive operation with this coset ladder and the code word. This element is obtained. Perform exclusive operation on this coset ladder of the second row with the code word, valid code word. This one is obtained, perform exclusive operations on this coset ladder and the valid code word. This process is repeated until up to all the elements in this example 64 possible valid code vectors are appeared in the standard array. Repeat above process for every coset ladder until all rows are completed. Ensure that every possible n-bit vector appears exactly only once. 60 out of these 64 code words that is not repeated anywhere in the standard array of this linear block code. Use the complete standard array for minimum distance decoding. This is very, very important. This standard array is used by the receiver, decode the receiver code words. This is the standard array as a matrix form, consists of 2 power n minus k rows and 2 power k columns. The number of rows are nothing but the rows. The number of rows are nothing but the cosets. At the beginning of each row, place one coset ladder. Coset ladder. Coset ladder is nothing but the error vector. Error vector. All valid code words are determined. 2 power k valid code words are determined with the help of this expression x is equal to m into g. All these valid code words are placed at the first row of the standard array. First row of the standard array. The remaining elements of these rows are obtained. Perform exclusive operations on the coset ladder with the valid code words. All these are valid code words. By using this one, coset ladder selection is totally based on minimum weight of that error vector. With this, one important drawback is as n value increases, the number of rows are also increases, number of columns are also increases. It is very difficult to maintain such type of standard arrays for decoding for purpose. That is the drawback, but reliability is more. It is used to extract the code words, transmitted code words from the transmitter, and also it is used to extract the error vector. With this completed, explanation is completed.